Welcome to the 94th episode of the New Ventures podcast. I'm your host, Sanjoy Sanyal, the founder of Regain Paradise, a boutique climate finance firm and a visiting fellow at the Cambridge Judge Business School. I try and understand the links between climate change and food security in these series of conversations. Our guest for today is Vasco Esteves, who is the CEO and founder of Tecma Foods, who is developing innovative solutions for using insects in both animal and human food. He's also the president of Portugal Insect, an industry association. Welcome, Vasco.
Hello, Sanjoy. Thank you for this invitation.
Let us just understand who you are. Why don't you introduce yourself to our audience?
So I'm from Portugal. My background is business economics, but I always felt an attraction towards food production. Before going to business economics, I thought it would be nice to do animal production or biotechnology. But I went there, spent there a few weeks, but I realized that that's not the way I want to go. I want to first understand how the business works. And then I went to business economics. But the passion for produce food and animals, it was always there. And my childhood, I spent many days on my grandparents' house. It was a farm with animals. And I always thought it would be nice to have new ways of producing food. That's how it started. Also had in my father's house, always I had exotic pets such as reptiles, snakes, exotic mammals. It's a thing that I have from very young. And from very young, I started breeding insects for feeding my hobby. It was quite expensive back then. So I started to test it in a small scale to produce some mealworms, some crickets, also some roaches. And I think it started then. Then my career went to logistics, also to textile factories. And then it was like a eureka moment. I realized that I could start raising insects and there was some potential for this new industry.
It is fascinating how childhood comes back to us and then leads one to one's new business. Tell us a little bit about what Tecma Foods does.
So Tecma Foods started as an idea. I said before, in 2017, I started to see an emerging tendency. There was a lot of buzz around insect production, mainly in Europe, France, and also Germany. There were some companies emerging. And I thought it would be nice to go back to my childhood experience and start to test how this new industry emerging, how hard it is to scale it, what insects could be used for feed and food. And that's where Tecma Foods' journey started. I quit my job. I was working for an international firm. And I went to my backyard. I mounted a container, a climatized container, and I started with around 8 species of insects, grasshoppers, different types of worms, black soldier fly, crickets, and some cockroaches also. And I tested different types of production methods. There was not enough information available back then. So I went to scientific papers and tried to mimic what they were using on those papers, some techniques, densities, temperatures, sources, etc., etc. And during around 1.5 years, I tested by myself in my backyard. And also I mounted a small kitchen. It's a very small kitchen with different types of drying methods, different types of mills, and it took me around 1.5 years to select a champion. So I started excluding the other insect species based on metrics. So some of them die a lot. Some of them were really hard to manage. Some of them fly, which was the difficult for maintain. Some of them they cost a lot to set up. So based on multiple criteria, I started to exclude. And at the end of this time, I finished with 3 insect species. So cricket, one type of cricket, the aketa, one type, of worm. It was the mealworm, which is what Technofoods does today, and also black soldier fly. And then I went to the hard part. Back then it was really hard. It was to cook them and to eat them. And I end up selecting mealworms because the taste for me, this is a personal experience, personal opinion, the taste was very, very good. And I still have some pictures and some films when I first tried insects and start to cook with them. It was an amazing experience. So segment food started there in my garden, in my backyard. Then I went to scaling up. I raised my first investors. I started as the 3F, so friends, family, and fools. My dad supports the start of the company, and my wife and my brother come and join and help us to build the first factory. That's the story of the beginning of tech.
It's amazing. I'm almost tempted to think about that in our promotional video for this podcast, we will have the old video of you tasting this food for the first time. But just to get on with this conversation and finish the introduction section, tell us a little bit about when was Portugal Insect, the industry association, set up? Because then I guess by that time you realized there are other people like you.
I was not one of the founding members of the Portuguese Association, so I joined later. I joined in 2020, but it was founded by three parts, so three different entrepreneurs that already were working at the market. So they were working on the feed, on the food business. So they joined themselves together because in Portugal there were basically no projects on the insect production back then. You look at France, Germany, Sweden, there were companies establishing there. In Portugal, there was none. So they came back together. I later entered to this Portuguese association, and then I've been working and trying to set up the Portuguese system from 2020. And the main goal is to try to establish a direct connection between the Portuguese authorities, because back then everything was new to them. Regulatory issues, how insects are produced, how insects can be transformed. So the legislation was already being written for all the European countries, but local authorities, Portuguese authorities, they had a lot of difficulties to establish local legislation, local rules, how to permit this new activity. And they call me and they ask help from me to make some calculations and to help them to make the grounds, the legal basis to start the insect farm. That's my point of entering the association, is to help the Portuguese authorities. And it was an interesting path to see that the government was very enthusiastic. Of course, they put a lot of resources on this. Normally, we think that the governments are really bureaucratic. They don't want to change, but that wasn't my experience. They were very kind and very open to look at this new emerging sector.
Let's jump in and start talking about the applications. You already mentioned, and I found that amusing, that you actually ate the insects in the early stage of your business. But in the mainstream food business, what are the applications of insects?
We can say that insects as a food ingredients are within the ramping up phase. So it's still a niche. For now, only the first adopters, the companies that are emerging, that they are only focused on insects, they are the biggest market right now. The regular food business is not yet using many quantities of food ingredients based on insects. But it takes time. We'll get there, but the applications are huge. So we can pick up the insects, for example, for food. Mealworm, in my opinion, is the best species. It's a very stable product. The smell, the taste, the nutritional content is very balanced. So we have protein that it's very rich, around 58 to 60, depends on the producer. But also we have very good oils. So oils that are rich on omega-9, they still have omega-3, but more 6. So it's a very flexible product. Since it's dried, you can do it many ways. Then it can be grind to a thin powder, and it can be used on protein bars, shakes. It can be used on all types of pasta. So if you are already using some type of wheat flour, corn flour, you just need to substitute a little bit, 5 to 10%, and you create added value on the product. So you are bringing protein, you are bringing very good oils, very good fats on the product. So these are the main applications, but there are many. And then you have the old insects that can be sold as a snack. But in my opinion, on the future, that will be the smallest part of the business. Right now, it's one of the biggest. It's to sell the experience. So I'm eating whole insects as a snack. So it's an experience. It's not just food. But if the industry grows as we expect to grow, that will be a very small part of the business. And the main business is to have ingredients, ground powders, full fat or defatted, to be both, into normal products. Pizza, you can do cakes, pancakes. I think it's a very huge universal applications. Very, very big. Hamburgers also.
What about for animal feed?
For animal feed, in my opinion, the best species will be black soldier fly because it has lower cost of production for if you compare to mealworm. Both of them will have different rules. The mealworm for food, black soldier fly for feed, and within the food market, you can put grasshoppers, crickets will be also interesting. On the biggest players will be mealworm and black soldier fly, for my opinion. And for feed, the difficulty is to lower the costs in order to be competitive with fish meal and soy meal. That's the goal right now of everyone, but scale up takes time. Industrialization takes time, and in these industries, they are very heavy on capex. So it's very difficult to have a sustainable model that can, on the short run, decrease the production cost in order to be fed to animals that we are going to eat after. So I have no doubt that the properties are very, very good, anti-inflammation properties, antimicrobiology properties. So insects have things that soy doesn't have, that fish meal doesn't have, but the price needs to go lower. That's the thing that the industry is facing right now. Investors are already cutting off some part of the investment. So the mega factory, the centralized model, is being tested, and the two biggest European players are in trouble like right now because they focus on feed, and it's very hard on the next 5 years to compete with the fish meal and the soy meal. But I think it's possible. It only takes time. If you look to poultry business or swine production, it took like 100 years from small farming operations to mega operations. So insects are being pushed to make this change of 100 years into 10, which is really hard.
Which is, I think, the reason why you mentioned those words of caution right at the beginning, that we have to be careful. And I think one of the ways you're being careful is that you are partnering with large companies to test and develop products.
Correct. I prefer to grow organically, to go and have a business operation that is driven by demand. And also, in the beginning of industrialization, I have to take a decision, and it were two models available. Back then, it was only one: is to centralize everything, make a mega factory of insect production, raise 100 million or 200, what was available back then, and then hope that everything goes all right. But if you look to all the other industries, poultry, fish, aquaculture, swine production, pig production, etc., all of them have a similar model. So it's a decentralized model. It's integrated, but it's decentralized. So we are putting the technology where it's needed. You are putting the animals near the food source or the feed source, and if possible, you are putting all the streamlines, so the fertilizers, etc., near the end user, so the farmers. If you centralize everything, it's really hard to have this. It looks simple, and you don't have the logistic operation. It's a fact. But then you have all the inflows of inputs and all the outflows of outputs. They have a huge impact on the land where you are seated. So we started to grow organically, specialized operations. So one factory focus only on breeding, which is really hard. And then I will go to partnership with farmers and give them the technology to raise the insects in order that they can use local feed materials, especially wet products that they go from good to bad very fast. So they start to decay really fast. And then they can use those side streams. They can use local labor and create job opportunities there on the rural areas. And then they can use the insect fertilizer to put on their own crops. This is the most strongest model. We also try, and we are doing right now, it's to grow to go to companies, food companies, not only farmers. And okay, you have a network of farmers in a radius of 50 kilometers. They need your, for example, pomas, or pulp or beer spent grains, and you can give them and they will collect here, and then you are starting to build a network. And that's how our strong business are created. It's not to only focus on yourself, everything in your company. No, we need to go and expand outside of the company. That's my concept. It's to minimize risk, to bring people into this insect industry. And by using this integrated model, I think we can really create a model that works. Also, if you centralize everything,
the way you're talking about the partnerships, both at the farmers level as well as the food companies level, is for the production part of it. Don't you have to partner with animal feed companies to test the product, figure out, the nutritional elements, the ways to mix, how the food feed companies will use this insect in their current feed products?
for sure. And I always count with academia to universities to help us because they do a really good job on this. So we also work with many universities in Portugal. And now we are going abroad also and to partnership with them, test it, and to mount a cluster. So I cannot do it all myself as a company. So I need to partner with this, first with the feeding company. So the companies that will give us all the byproducts, I need to then test it in the insects and see if it works. Sometimes we don't have that information. And also I need to partner with the end users. So all the food companies that want to test the insect products in their own production. Of course, this is a chain. It's a value chain that needs to be created. So we try to partnership from the beginning of the supply chain into the end, even with logistics. I think that's the way to go. In terms of animal feeding, since our company is not focused on this, we did some tests, but most focused on our side streams. So how can I use my side streams as the feed ingredient to animals? That's our main effort right now because the mealworms, the ones that are good, I'm canalizing all of them to food applications. So the rest is going to feed. And there is a niche there, which is the pet food business, which is a very good business with higher margins. It can solve part of the problem of the costs. And today's pet, in our days, the pet is like family. So they are willing to spend a little bit more money if they see that there is advantage for the health of the animal. So joints, fur, etc. We also partnership with big companies in the pet business.
On the animal feed, and I get the point about you focusing on the food business and then using the byproducts to test an animal feed business. On the animal feed business, would insects like black soldier fly be better?
In my opinion, yes. It's not a question of better. All the studies that we did, mealworm had a more interesting nutritional profile than black soldier fly. But in feed business, it's always a thing of gain and cost. So I think black soldier fly would be best for this type of animal production, for feed, for poultry, aquaculture, etc. Because if you can decrease the cost, if it stays the same, I don't see it. It's going to be very difficult to feed insects. That's why we went from, if human skin in insects, I prefer to give him the best insects in terms of nutrition profile, which is the mealworm. But I think there is a big opportunity for black soldier fly using a similar model to us. It's by having all the animal production have their own units, so that they are producing in the farm. So the live larva, so the live black soldier fly, they can use a side stream from the farm, and then they can feed directly live larvae to the animals. I see a huge potential here because you are not only giving nutrition for the animal, but you are giving a natural stimulus for chickens, for birds, all types of birds, and also for pigs. So you are giving a natural way of feeding that is proven by science that will enhance the natural behavior of the animal, and that has an economic impact. So if my poultry is very good in terms of behavior and health, I have low cost, I have low death, for example, or increased egg production. This has been proven, and I think this model can really work. So decentralized and feeding the live larvae to our feed animals.
Right. The point about pigs and the chicken eating live insects is, I think, also very interesting because that's pre-industrial world. That's what, or in a small poultry business, that's what these birds eat.
Great.
You talk about newworm. Basically, you work with this insect, whose scientific name is Tenebrio mollitor. Is that what you mean by newworm?
Mealworm, exactly. Mealworm, it's a common name for Tenebrio mollitor. That's correct.
Right. And then, let's talk a little bit about costs. I know it's early days of the business or the industry itself, but essentially what you're saying is that for animal feed at this point of time, the costs are far more than the existing products because there is a scale issue there, right? And one reason for that is the capital costs are large for insect feed. But we also know that scale can bring in very quick reductions in price. What are the magnitude we are talking about here?
When we increase capacity, normally we'll decrease the price. That's basic economics, but we cannot forget that we are dealing with animals. So it's not put everything in the Excel and hope that everything's going all right. So there is challenges on ramping up production into a huge scale. Technological products that are pace by pace are being solved, but till today there is problems there. And in fact, capex is a huge issue because we still are developing the technology. There is not enough technology providers on the market right now. There are a few, but even that, in my opinion, they are still testing. So everyone is spending more money than it should because everyone is trying to develop their own methods. So it would be nice to have the companies that have experience on infrastructure and also in climate controls, on poultry business, so they already have that knowledge, and then can be applied to insects. There are a few cases in there, but imagine you have now fish meal around the price. It went down on January and February. I think it's just 1.8 thousand euros per ton. So 1.8. It's already a finished product. We are not talking. I'm not talking about the live fish. It's already processed, stable, and ready to use. And right now, on my knowledge, in Europe, okay, I'm talking of Europe production, because there is a problem there. The norms are very demanding, and Europe is really regulated in terms of food production, as you may know. So the costs also go up. If you compare with producing insects on China or any part of Asia, it will be lower, not only to regulation, but also to other types of costs. But if you can compare 1.8 thousand euros per ton of fish meal for 3.8 thousand euros of BSF meal, so it's more than double. It's almost double. And this is the lowest price I can find on the market. And I don't think it's sustainable. So there is some money there financing the operation. For me to be perfectly normal to see 5,000 euro per ton of BS soldier fly of a good quality. So it's always double or triple. So it's very hard to finance an operation of feed business because the margins is already really, really, really small. But if you go to live larvae can decrease a lot, because the rule of thumb is that you need around 3 kilos of live larvae or any insect species to produce 1 kilo of protein powder or 1 kilo of dry milled insects. So you pick up the production cost of the live insects and automatically you multiply by 3. So if you are feeding the insects live, you can decrease the cost just by using this.
Which essentially means that we need to develop the products and, as you mentioned, the technology. Let's move a little bit and start understanding why we should do this. And we haven't talked about the climate benefits, but essentially, when you are replacing animal feed, you're replacing soya. And so, there is an emission associated with soya production. And so, theoretically, insect feed will have far lower emissions because you're producing it in a more contained atmosphere. But there's another reason as well, right? Which is, I think you kind of alluded to this a little bit, that insect production, the input is often food wastage.
Yeah, I think that's the elephant in the room. If you use it side streams, of course, insects, if you compare with any mammal or also with poultry, they are very efficient. So they can transform the biomass of what they are eating into their own biomass really well. So you automatically have a gain there. Okay. Even if you imagine a scenario where you are feeding soy, corn, and barley directly to insects, even that the impact will be lower because they are very good transforming these food materials into their own body mass. But that can work on this basis, and I think we'll have operators that choose to give a stable feed material, high quality, the same as you are giving to poultry, because they want to have a better product. So, for example, food application. And having a stable feed material, you can solve many of the problems that insect industry have when they are using side streams. Because side streams, they have seasonality. You can find some of them that they don't have, but most of them, but we are talking about spent fruits, spent grains from spent vegetables from markets, etc. And you have seasonality. You don't have much big control on what you receive. There are ways of stabilizing that, but that's a challenge. But is also the opportunity. Because this is my experience from Portugal. It can be different in the different countries. But right now, side streams, you already pay for them. Back then, 10 years ago or 5 years ago, the companies that were producing the side streams, most of them, they were paying to companies or to the government to collect the side streams. But right now, the good side streams already have a price. So animal feeding is already using that, and also for other applications. So the balance is to find a side stream which has a very fast decay that can be used to feed insects, because insects will eat accept more rotten products, more decaying products if you compare with the other animals. I think the opportunity is here is to use these more complex side streams and insects that grow really well on these products. And you cannot feed, for example, you should not feed to a chicken. They can eat, they can be missing, because the insect they have their own mechanisms to maintain the colony health by using peptides that can decrease the microbiological problems there. So bacteria, fungus, they have these tools that other animals don't have, at least on this industrial application. So I think the biggest opportunities there is to avoid importations of feed materials and to use what is already being used on the country or on the region, normally to end up on the landfill.
I'm actually pretty keen to understand your installation that you have done near a brewery. Are you having the same problems? That is, the brewery waste is not stable, or is it stable? And just tell us a little bit about that project.
We select the place of the factory, of our insect production factory, near brewery and also near some industries that produce vegetable drinks, vegetable milk, you can call it. So they have a lot of spent grain that if it's not dealt on the same day, they will start to fermentate, and that can cause problems to the brewery factory. And normally they have daily pickups of this spent material. So we try it, and the mealworm, so the Tenebro molitor, they thrive on this. They really like this. They grow really well. But at the end, we stopped using it because it was causing us problems on our final product. Back then, there were not the technology, was not there. The technology to deal with the left that the insects did not eat, so we stopped it. But now we are working more with fruits that are being decayed because the insects completely eat everything. So we collect from the companies that send us spent carrots, spent apples, etc. on an industrial case, so it's stable during all the year. So there is always carrots, there is always apples on these big companies. And also we have a pilot project with our local markets, so much vineyard markets. It was a partnership with the city chamber, and we collect 2 days per week all the vegetables and all the fruits that were not selected, that were damaged from the market. And then we stabilize everything into a vegetable cutter, and we feed the insects. Working really well, and we think that we can grow and use all the materials from local markets because they are already divided. So in local markets, normally you don't mix fruits and vegetables with meat products because that is the biggest challenge right now. I cannot use side streams with animal products. European law doesn't permit, but this is being discussed because the insect will eat everything, fish, meat, and there is no microbiological problem there. They can handle. But right now, the European law don't permit this. But on the future, this will unlock a lot of side streams. Schools, hotels, casinos, meal preparations, shopping centers. So all of these post-consumption waste, since normally you cannot separate the meat from the rest of the waste, they will be available on a near future. And I think that's when the insects will have a big impact on the food waste problem.
That's when the insects will have a feast. But even before you go to the post-consumer waste, which is a big waste, in the examples that you provided, the brewery waste, the food company waste, the market waste, to understand the climate benefit, if you were not there and you were not picking up those waste materials, how would those wastes have been disposed? Would they have gone to the landfill, potentially creating methane emissions?
That's exactly the point. So we did a R&D study internal, and we go to outside sources. Normally, this is going to the landfill to produce, even in some, but normally it can be just put on the landfill. But even if you compare with some of the cases that we discover, that will be decaying by bacteria, fungal, and some of them by regular worms, the emissions were higher than using mealworm. And this is specifically for mealworm because they don't emit methane gas. There are other insect species that have emissions that need to be controlled. But for the mealworm, it's perfect because they don't emit. They are not capable. They have the bacteria in the gut to produce this. And the guts of the mealworm, of the Tenebro molitor, it's amazing because it can transform plastic into organic matter. And that's, for me, it's not a project that we are in right now, because it have many challenges. You cannot feed insects that eat less plastic and bring them to the food supply. But this is to show how powerful this tool is.
The other benefit, which you kind of probably mentioned in the passing earlier on, is that the production process leads to manufacture of fertilizers, which your farmers can use.
Exactly. Insects fertilizer is very good for the soils. You can look at, if you can compare with a normal fertilizer, The ingredients there are very good. But in addition, there are things that the other animal side streams or the animal fertilizer doesn't have. The frass, which is the commercial name for the insects' excrements, also have chitin. And chitin, which is the exoskeleton of the insects, is also very good for plants. So we are not just looking to a regular fertilizer, we are looking to a biostimulant for plants. So chitin will induce the roots to grow stronger and healthier. It will give the plant an immune response and bring the best of the plant. This is already being studied from many papers, and the impact is really good. So we are giving to farmers a very good product, not just not fertilizer, but it surpassed that. So it's a tool, very good tool.
Well, here's a question. Is it the insects themselves which is the organic fertilizer, as in you manufacture insects not as for animal feed, not for food additives, but for organic fertilizers? Or is it the byproduct or the waste stream for insects, for animal feed, and for food that is the organic fertilizer?
The organic fertilizer, it's the excrements that the insects are eating. So they live in the food that they eat. So that's where the colony stands. They eat everything, and during this period, they will transform the feeding materials into this amazing fertilizer. But also they shed a lot. They have a lot of skin there, so exoskeleton there. So this fertilizer is a mix of insect poop, of insect excrements, of insect sheds with chitin, also some parts of the feed material that they did not eat, for example, which is a small part, very small. They eat almost everything. And this is the base of the fertilizer, but also we have some side streams. For example, you have your breeding colony. And in the mealworm case, and also on the black soldier fly, normally you will not use the adults that eventually will die off. So they have a short life cycle. They give the eggs that we need. At the end, we need to look at how can I use these breeding adults, since they are not very good for, at least for food. You cannot use it. So they have some compounds for mammals, for example, are not very good. And then normally what insect companies do, they pick up the leftovers of the production and they add to the fertilizer. So they are enriching the products with exoskeleton, with proteins, with more chitin. So you can legally do this, mix the leftovers from the breeding part within the fertilizer and create a better product.
Because you mentioned the study earlier on, and if you can talk us a little bit through the production process, take us from where a factory which makes insects for food, for example, where it starts from and the output, and just help us understand where is energy needed in the process, because that will help us make the comparison between the emission factors of today's normal food versus the emission of insect-produced food.
We can divide, in my opinion, the insect production cycle in three bigger parts. So we have the breeding, then you have the growing, the fattening, and then we have the processing. And normally this can be done they should be done in three separate buildings because they have different needs. They have different technical needs in terms of knowledge, but they also have technical needs in terms of energy, as you mentioned. And we start breeding, and breeding, what we normally do is we take out the bigger insects at the end of the fattening cycle, and then we collect around 2 to 5% of them. We select them based on the genetics. It's artificial selection. We are using mechanical processes to select the bigger ones, the ones that with the same resources became adults or pre-adults. And then we collect and give them time to transform into adult insects. On the case of the Cinebrio molitor, it's from larva to pupa, and then to pupa to a beetle. And that's when the beetle can reproduce and start laying eggs. So this facility normally works on a climate around 25 degrees. So what we should do as an industry is to invest on the lower consumption climate control machine technologies. For example, air conditioner with the solar panels, for example. And this is the thing that I do a lot. It's to focus on having the correct technology on the correct phase. That's why I try to divide them in three or more. In the breeding phase, the insects, they will need around 25%. So energy consumption is not really huge. You can maintain the temperature, reuse the air, use technology to clean the air, but use the air which is around 25, already 25 degrees, etc. And then you went to the growing phase. So the growing phase, you have first 4 weeks, you need a lot of heat because you need to incubate the eggs, and the mealworms are so small that they cannot generate heat. So you need around 28, 30 degrees. And then the last 4 weeks, you need to take the temperature down because the mealworms will start to produce a lot of heat. It's amazing. They produce a lot of heat. So what we do is try to balance these two different phases. If I need heat first, and then I have another part of the facility generating a lot of heat, just connect them. Just put fans drawing out the heat from one phase into the other, etc., etc. If everything is looked at this detail, insect production can have a lower consumption of energy. And if you cross this, of course, with solar panels, with other technologies, you can lower the consumption very, very low. At the end, we have the transformation part. So it's the food facility where the insects, in this case of larvae, already separated from the fertilizer. This is done on a press step facility. You cannot have insect poop on a food factory. Then you clean the larvae, you can wash them and reuse the water. That can be very easy to do. And then you dry them. And here you need, of course, a heat source. It's electrical heat source that you can also use solar panels. There's no problem there. And also you'll generate a lot of from extracting the moisture of the mealworm. So you will end up with a facility that consumes energy, but also release a lot of vapor. So water that is being taken out of the insects in order to stabilize them, and the air from these machines, they will exit around 60 degrees. So you can take this energy and use it on the facility, on the breeding. So we are warming up the facility with this vapor that will come out of the drying machines. So if you think on a holistic way, it's very easy to minimize the consumption of energy. And of course, the materials that you need, the construction materials that you are going to use, they need to be insulated. This will decrease the energy cost, the energy consumption. And so it's doable. We are still learning, but there are tools there, and we are doing it in a controlled environment.
The point that you're making, I think, is clear. This is some ways a standard manufacturing process. Yes, it is manufacturing of live animals. We can draw inspiration from how the poultry industry, for example, reduces emissions in the production process itself, energy efficiency, renewable energy, use of waste heat, and so on and so forth. But these are known issues, as opposed to how the animal is going to be used in animal feed, which is the harder problem. Bhaskar, you've done a really great job of laying out the industry. I have a few questions about your company. You started by saying friends, family, and fools, raising your first capital. But after that, you made a lot of progress, right?
Yeah, it's true. It's been an interesting journey. So we started as a family company, and then we find out our first investors, so institutional investors, like them, business angels and others. Then we went to VC money, venture capital. We already have two of them, and now we are closing up our seed round. It's going really good, but I'm always careful on selecting the partners, because normally what we see in the last years is to have investors that are not aligned with the reality of investing in industrial company. So if the expectations are really short, because technology for industry takes time, not software. It takes time to develop. If the timeline is not aligned, you have a problem. They will pressure the company to make things that you are not ready, and then you have a problem. So that's what we did in Techmafood. We select investors, and they selected us, of course, also to be part of this journey for many years. I think that's the key. If you are going to fast money, it's not going to work. At least with live animals, it takes time, trial and error, a lot of trial and error. But we are now in a phase that we have capital enough for the next 2 or 3 years. And also there is a lot of grants available on the European Union. And that's part of, you have the downside of having a heavy capex company. Normally there are grants that can help these companies. So there is a really clear focus of the European Union in order to have sustainable fruit production within the EU territory. So there is a lot of grants. So we already were selected for one, and now we are working on more 3 that can help us to grow. But even with this, my main objective is to the operation being economically stable. For me, that's my first goal. It's to have all the operations scalable, but at the same time can pay the bill at the end of the day. And we are almost getting there. So that's, for me, it's going to be a very important goal.
And in terms of scalable, in terms of getting enough economic value, I think your technology licensing model is going to play a big role.
Yes, we thought a lot about this. Our doubt is, should I give this knowledge that costs a lot from us to develop to third parties? But in the end, if you look to the investment needs, having partners that go along with you and reduce the capex, in my opinion, it's for now the only way to grow in a sustainable manner. So they also invest with us, and this can be done. It's what we do. We have a waiting list of projects. So partners come to us and say, okay, I have an industry, or I have a farm. I really went to this business. I have financial capacity to invest on X units from 2 to 16, or we work on modular farms, with modular farms. And the big decision is the distance to the hub. So the more far you are, the more units you need to have to pay for logistics and to stabilize the operation. But even that, the partner can choose to, okay, I will try to. Because all right, I will upgrade to 8 or 16 or 30 units. And what we do is we convert containers from ship business that are already some or damaged, or they are not being used right now, and you can use it. And also, we are taking advantage of one thing. There is a lot of poultry warehouses, a lot of them, that are now not being used in Portugal. And the structure is there. The license and the occupation of the soil is already, we have green light for poultry or for animal farming. So you can cut some of the time it's taken to legalize everything. And we are also using resources that are there. So the building is there. It can be a little bit damaged, but we always need to put insulated materials in order to retain the temperature and decrease energy consumption. So having partners with us on the capex side, it's really good.
So what I'm trying to understand, and you have a nice little name for it also called iRanch. So in an iRanch model, I have several questions because it's all so interesting. Let's start by, why are these poultry warehouses in Portugal not being used today?
Okay, that's part of the industrialization of the poultry business. On the 80s, there were around 200,000 small poultry production warehouses. So mostly of them were family production. And then some of these families start to invest on bigger and bigger and bigger, but eventually 4 to 5 players, they were able to sustain this model financially, and they stopped using those third parties and they focused on new, bigger, and more technological warehouses. So there was a shutdown of these more family businesses, family warehouses of poultry.
And that is because the poultry industry really works on the economies of scale. Costs have been driven down because the bigger the scale is and the faster the bird can grow, to a particular size reduces costs. So that's really interesting. And so your partners, if you may, are family businesses which used to perhaps run poultry business or similar, now running an insect business. And what do you give to them to start them off? I mean, you must be giving them some technology, know-how, and of course, market knowledge.
Yeah, we use the integrated model that poultry also use. So what we do is we supply them. If already there is, for example, abandoned poultry house, we supply them with the designs, with all the technology that they need to install in order to that place to be able to raise the insects. And there are more competitors. There are more companies doing this besides Tegma Foods. We focus on have materials that can last, materials that can be used by farmers, and materials that can. And we know that farmers don't have tons and tons of money. So there are some competitors that use AI, mechanization, and everything, and you will end up with a container of 40 feet, for example, that costs 100,000 euros. In my opinion, that's not sustainable for the Portuguese farmer or even for most of the farmers. So we focus on giving them small budget solutions that can work, that can be operated by anyone. And the only thing that we retain in terms of knowledge is the sensors that we install there. So temperature, light, humidity. And we have our platform where we can control and assist all of the raising cycles. So we have where we have our team, we can see if everything is going okay in terms of these three parameters. The rest we give, of course, the knowledge, how to feed, how much, the frequency, and what temperature conditions you need to have, what tools you need. Sometimes, in some cases, we even give the plans to them and give everything. So, and they can source locally because it will be cheaper than our team to go there and to assemble, etc. So we want this to really work.
So this is interesting. So you sort of tell them how to do it. You monitor that using data and sensors, but you don't ask them to spend a lot of money. I mean, you try and make that reasonable. So my question is, how reasonable is reasonable? And when the insects are produced, how do they sell?
That's a way to minimize risk for them because the market is still small and we really know the market. And we don't want the farmer to focus on commercial because he doesn't know a thing, or normally they don't know anything about the insect market. So what we do a contract for a period of time and we supply them everything they need. We supply the technology, information, and the eggs. So we never give them because this is really hard. It's really hard to have this is the most difficult part to scale up. It's the breeding. So that's where we focus our capex and our knowledge and our team. And our focus is to give them a good colony of small baby larvae cards and do the job. And the only job that they need to feed and monitor and fatten and grow. And at the end, our contract will buy from them all the larvae and all the fertilizer. This is a standard contract. Or they can also have part of the larva, for example, if they have poultry, but they cannot transform the larva. They need to use it live. And also the fertilizer they can buy from us at a really low price. And they can use it or they can make business with other farmers that are around them. So we guarantee that everything that is produced is being consumed and already being sold. And for us, that's why we are limited in terms of growth. I will not accept a new farm if I don't see an opportunity, I don't have a clear demand from a potential client. Because if I don't have it a client, I will have to pay. It will be a cost for me. And I have to be sure that the farmer can receive what I promised to him. So this is an equilibrium. It's having deployed more farms.
By client, you mean a food company which will buy the insect. I need to produce, whatever it is, and then I need farmers to do that, right?
Exactly.
Yeah. And then just to get a sense of this, if I were a farmer in Portugal, how much would I need to invest to start a relationship with you?
We started to as our modular business. So if you don't have a warehouse or a structure, we started with the iRanges as our modular units. And for 2 units is around 36,000 euros. And this is also including all transportation, installation, everything. And even we will help you with the licensing. So we will help the farmer that doesn't know how to register, doesn't know how to receive the permits. We give them all solution, turnkey solution that can they use. So it's around 36,000 euros for 2 units, okay? And as we go up to until 16, which is what we have, the biggest farm on this modular regime that we have is 16, it will be around 180 to 100,000 euros for this unit. And we are guaranteeing a payback of 4 years.
And to start off, then I get this initial larva from you, and that
Yes.
starts the breeding process and the growing process of the insect. And then I source the waste from nearby markets, or maybe there's a brewery nearby or whatever, right?
Exactly. That's the work that you need to done before you come to us, or you can help. And before investing, is to first checking what type of wet materials or feeding materials you have on a radius of 50 kilometers, maximum 100 kilometers. That's to have a low print on logistics to decrease the impact. So after done your work, if it's a new product that we never tested before, what we do, it will test it in our facility for a new fruit pomace or a new paste that we never tested before. We can test it and see how effects it will affect the larva growth and also the nutritional part. And then we can go into the setup phase, which is fast. So we can order from our partner that makes a structure and refurnish all the containers. And we can install with a crate and a truck. It's put on the ground and it can start working. You need to have electricity there, of course, and water source. But beside that, you don't need nothing. You need ground. It can be sand or it can be dirt, whatever you want. And what we also help the companies and the partners is to see if they have labor fluctuations. For example, if I have a farm that is normally have one person, but sometimes need two, it's nice to help them calculate how many people they can have permit on the farm, and they will also be being used the labor on this operation. That's the thing that we also do.
When I get my first larvae, what is the cycle? Like if I'm growing poultry, then I can grow poultry in 56 days. That's something that they're probably familiar with. How long does it take to grow insects till I can get my first sale? And have people signed up already for this type with you?
The growth of the mealworm, the tenebrio molitor, it's lower than black soldier fly. So black soldier fly is the fastest insect in terms of growth. For the mealworm, what we do and the complete life cycle it depends on the materials that you are using. So that's why new materials need to be tested. So it will be around from egg to final size to be around 8 to 9 weeks. But when we deliver the larva to the farmers, they already have 4 weeks, 4 to 5, it depends. So, and for the farmer, after 4 weeks, I have the batch ready to sale, which is a cycle. It's really fast, so 30 days. 30 days to 38 days, it depends. That's how fast the cycle is. And for the second question already, yes, we deployed the first partner in 2021. It's near our hub. And now we already have 4 farms operating, and we have a waiting list of 40 projects, all in Portugal. That's our limitation.
Vasco, it's amazing that you're making this progress, because it's also bringing in the way I think about this. is that it's also bringing family farms back into the reckoning in the world food system.
That's true. There is a social impact there. Some of them are third generation that stopped being on this business, and now you are back and being back.
With that, we have come to the end of the podcast, Vasco. And if people want to get in touch with you, how should they?
You can contact me directly to our email from Tecma Foods, which is geral@tecmafoods.com. You can find that in our website, www.tecmafoods.com. You can find all the contacts there, and you can contact us. Or you can find me on my LinkedIn and contact me directly, Vasco Esteves. Try to look it, and it will see my image and the logo of our company there. Thank you.
It was wonderful speaking to you, Vasco. Really enjoyed this conversation.
I also enjoyed, and thank you, Sanjoy, for the invitation.